Today we're going to be talking about tree diagrams. A tree diagram can be used to show the outcomes of multiple events and then determine the probability of those events occurring. So here we've got an example of a tree diagram that shows flipping one coin and then a second coin after it. So flipping the coin, the first two choices are heads or tails. Then the possible outcome from a head might be another head or tails from coin two. Once again, if the first coin has flipped to tails, then it might have been a head or a tail. So this allows us to list all of the possible outcomes from using multiple coins, being involved in multiple events. So they could be. This could show a die being rolled, and this could show a coin being flipped then. But the die being rolled would have 6 different outcomes, numbers 1 through to 6. So the possible outcomes we've listed here are heads and a head, head, heads then tails, head, tail, tails then heads, tail, heads, and tails then tails, tail, tail. So there are 4 possible outcomes, and this is our sample space here. Sample space is heads, 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 tails, tails, heads, and tails, tails. So if we wanted to know the probability of flipping two tails in a row, we'd be able to see there's one outcome that shows there are 2 tails out of 4 possible outcomes. So the probability of flipping 2 tails in a row is 1 out of 4, so 1/4. If we wanted to know the probability of flipping a head or one head and one tail in no particular order, we can see there are 1 head and 1 tail in both of these outcomes here. So that's 2 outcomes out of a possible 4 outcomes. So the probability is 2 out of 4, or 1/2. The probability is 1/2 that would occur. So here's an example for us to look at. Example, we've got 3 fair coins being flipped. The fair coins means that it's a 50-50 chance. The probability is 1/2 that heads will come up and 1/2 that tails will come up. There's no weighting either side. The probability of getting heads and a tail is 1/2 each. List the sample space using a tree diagram for flipping 3 coins. How many possible outcomes are there? Find the probability that the first coin is heads and the last 2 are tails, and find the probability that exactly 2 of the coins show heads. So here I've drawn up our tree diagram. We've got coin 1, coin 2, and then coin 3, and the possible outcomes. Coin 1, possible outcomes are heads or tails. Coin 2, heads or tails, and coin 3, heads or tails, heads or tails, heads or tails, heads or tails. So the possible outcome might be a head on the first coin, a tail on the second coin, and a head on the third coin. This shows that all of the possible outcomes. So we can see heads, heads, heads is a possible outcome. Heads, heads, tails, heads, tails, heads, heads, tails, 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 heads, heads, tails, heads, tails, 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 heads, and tails, tails, tails. So there are 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes that we've got. 8 possible outcomes. So that's the total possible outcomes, and that is our sample space there, all of those outcomes. So we've been asked the probability that the first coin is heads, and the last 2 are tails. So it's got to be heads, tails, tails. So we can see here there is only 1 possible outcome when that occurs: heads, tails, tails. So the probability of that event occurring is 1 out of a total of 8, 1/8. If we are find the probability that exactly 2 of the coins show heads, so exactly 2 heads, we can have a look through our sample space. This one has 2 heads, we have 2 heads here, and we have 2 heads here. At the top we've got 3 heads, but we were told we want to find the probability of getting exactly 2 heads. So that's not exactly 2 heads, that's 3. That's 1 more than 2 heads. So we've got 1, 2, 3 out of a possible 8. So our probability of getting 2 heads is 3/8.